Bernoulli's equation is a very powerful principle because it allows us to explain many important natural phenomena that take place in the real world. Now, one particular example of a phenomenon that takes place inside our body that we can explain using Bernoulli's principle is called the Transient Ischemic Attack, or simply TIA. Now, a transient ischemic attack is characterized by a lack of blood to the brain. Now, before we examine how a TIA and Bernoulli's principle are related and how we can explain it using Bernoulli's principle, let's recall a bit of physiology. So let's suppose we're looking at the rear of a person's head, so at the back of the person's head. We have the left side of the body and the right side of the body. Now, how exactly does the blood travel from the heart to the brain? So let's examine the pathway that our blood takes. So the blood begins within the heart, which is found in this region. And the heart pumps the blood into a blood vessel called the aorta. And from that blood vessel, it deviates into the following two arteries known as the subclavian arteries. So the blood further divides, and some of that blood goes up to the brain via the left and right vertebral arteries. Now, these two arteries then connect to form the basilar artery, which takes the blood into the brain. So once again, the pathway of the blood flow to the brain from the heart is shown by the following diagram. Now, let's examine how a TIA takes place. So let's suppose that one of the subclavian arteries, let's say the left side of our artery in this section, has a partial blockage. And let's say that partial blockage is due to a process known as arteriosclerosis. So this process is essentially the hardening of that section of the artery. And what that does to that blood vessel is it constricts it. It decreases the cross-sectional area of that section of the blood vessel. Now, we know from the equation of continuity that the volume flow rate of our blood within the blood vessel network system is constant. So that means because the cross-sectional area times the velocity of the fluid within that vessel is equal to a constant value, if our cross-sectional area decreases, the velocity in that region must increase. So, because of arteriosclerosis, we have a constriction of this section of our artery taking place. That constriction decreases the cross-sectional area of that region, and that increases the velocity of the blood within that region. Now, recall that Bernoulli's principle states that where the velocity increases, the pressure within that blood vessel must decrease. So that means, according to Bernoulli's principle, we have a decrease in blood pressure taking place within this region where our constriction is taking place. So that means, let's suppose this side where we have our blockage is the bad side of the body, and this side is the good side. So notice on the good side, we still have the same exact blood pressure as before, but now on the bad side, we have a lower blood pressure in this intersection area. And so what that means, to compensate for that decrease in blood pressure, the blood found in the area with the higher pressure will deviate and travel back to this section. So the blood that was initially meant to travel to the brain via the right section of this artery will now return back to the section to compensate for that decrease in blood pressure. And so that blood that was meant to go to the brain will no longer go to the brain and will go to this section where there is a decrease in blood pressure. and this can cause a transient ischemic attack. So, once again, if one side of the subclavian artery, the left side, is partially blocked, let's say due to arteriosclerosis, the hardening of that section of the blood vessel, the cross-sectional area will decrease. Now, from the continuity equation, we know that if the cross-sectional area decreases, the velocity will increase to ensure that we have a constant blood flow within our blood vessel system. Now, by Bernoulli's principle, where the velocity increases, the pressure must decrease. So the pressure in this section will decrease. What exactly is the result? Well, to compensate for the pressure loss in this section of the subclavian artery, the blood rising in this section of our right section of the vertebral artery on the good side of the body is diverted down into the other artery found in this section. So the blood that is initially meant for this section rushes back down to this section, and so we have a lack of blood that reaches our brain. And now we have a TIA take place, or transient ischemic attack. So we used Bernoulli's principle to explain a medical phenomenon called transient ischemic attack.